So I've just pulled up at Armeg, who are the company that make drill bits and core bits and whatnot. They got in contact and invited me up just before Christmas, but hadn't had chance with everything that was going on to get up here. I've finally been able to get up here. So a shout out originally to Dean, who approached me about coming up, and today we're going to meet Andrew and he's going to take us through the whole Armeg factory. I've brought Dave Bishop with me just because you know, I've been doing a bit with Dave recently, so I thought I'd bring him up. We're going to go through the factory. We're going to be taken along, complete factory tour, shown how the raw materials come in, the drill bits are made, the core bits are made, the furnaces internally, how each separate component is made within the factory, and, you know, the end product at the end. So massive shout out to Armeg for inviting me up. Hope you enjoy the video. We'll have a little bit of a tour of the factory and see what products they do just outside Sheffield. So I don't know how much you're going to be able to hear me, but we've had a brilliant introduction here at Armeg. Andrew, a guy I'll introduce you to in a minute, he's been taking us round. We've basically had a massive tour of their whole factory here, from the raw materials coming in here to the end process going out. So I'm just going to quickly show you, take you through what we've been shown. Hopefully you can hear me all right, but yeah, we'll go for it. This is the drill bits coming in as a complete raw material, the different thicknesses, and this amount of raw material here will last these a few months, and then it begins to go through into the machines as we're going to move along. This is Andrew. He sort of took us around the factory, so we'll go through with Andrew now and just point out some of the main parts of the process of making what they do here at Armeg.
Fantastic. So if you want to follow me, so this is what we call the starting off area. Okay, so this is filled predominantly with sliding head lathe. So sliding head lathe, this one's a great example. Okay, so this is a 10-axis sliding head lathe. Yeah. So if you look down the machine, you've got your bar feed along here, 4 metre long bar feed. So what the operator will do, he'll grab his raw material and load the bar feed up full. The bar feed will then push the material through into the sliding head lathe, and the sliding head lathe essentially does all the work. It does the turning, it does the milling, it does the parting off, it chamfers the component. It essentially comes off complete. So you'll have your 4 metre bar dragged through into the lathe. You can see the machine in operation inside. It's a new product we are releasing this year, which is the one-piece sprocket. Okay, so if you're just trying to envision that this has come off the machine in a 3-minute cycle time from one bit of solid bar. Okay, it's doing the milling operation at the moment.
So that bar's coming in through here, it's doing the milling operation here, the processing there, and then once it's done its little bit, it will end up firing it out the end here as one of these.
So this is now turning the back section. It's ready to pick it up, and you'll see it spit it out and fire out of the machine.
And that'll come out here now, will it? You want to pick up? They are?
Yeah, no, they'll be absolutely fine to pick up.
There you go. That is the raw one that's just been made.
So this machine will run all day, all night, and every 3 minutes it'll spit one of these out.
So it's literally working day and night.
Yeah.
Chucking those out.
Absolutely.
Perfect.
Absolutely.
So these are what us as plumbers use. You know, like the actual core bits before the teeth have gone into the top of them. They start out as just a big lump. Is it steel?
It is steel.
So it's a big lump of steel, solid lump of steel, and then this machine will basically turn one of these with the little thread in the back to obviously go into our extension bar, and then it will have later on, I'll show you how the tungsten bits, is it tungsten?
Tungsten carbide.
Tungsten carbide brazed into here. But this is the machine that makes those from those blocks there.
So if you take a look in, we've got one prepared from earlier. Okay, so you can see how.
So that's that block.
Yep. So if I shut the door now and press go, you'll be able to see it in action.
That's where the wizardry is. So it's obviously cutting into it there. And what's the time to make one of them?
6 minute 18 seconds.
So you've got 6 minutes from that raw block to coming out as one of these fully made up core bits. So these are the big sliding head lathes. You get the raw material going into here and then basically coming out. Are we right to put these up?
Yeah, go look it up.
And then they're coming out as this, and these will be for, these are the bodies for the core bits?
EBS range.
EBS
so
range.
for installing your back boxes.
Yeah, so that's one for the electricians. The back boxes, the EBS range will fit onto there, and obviously you've got your SDS fitments at the bottom. But they'll literally come through this machine, again, lathe out here, and there.
So one bit of raw material through the lathe and out completely.
So what's also really nice here is that they've got all the, you know, the really expensive new high-tech machines, but also they've got a lot of the old stuff, the old machines from years ago that are still doing what they need to do. At the end of the day, I think these machines are quite cool looking, but yeah, it's nice to see the new stuff and also the old stuff as well.
Right now, what it's going to do is it's going to put a little bit of glue in.
Yeah.
So the robot's telling it all to do it. It's going to come over across here, pick up a magnet, and go across that magnet.
Just drops it straight in there.
Yeah. Then it blasts the air.
And that's it, sealed in.
Yeah. So,
and again, this will just run all the way through the day. You're even...
Will these run at night as well?
Yeah, that's your project you're working on at the moment,
so
isn't it?
it's still in development. As you can see here, we've got the tube's not finished, it's a small tube. So we trialled it overnight, and then I'd probably say it did about 90% and then just tripped out. So the problem with this robot is that if there's a certain amount of force applied to it, it will just come up with saying excessive load.
Right, got you.
So that's what lets it down at the moment.
But no, it's doing its job during the day.
So these are as roofing bolts, obviously.
Yeah.
So the idea behind putting the magnet in is just to improve on the ergonomics, just to make them more user-friendly, so you're not forever dropping the bolt. Rather, it's a very labour-intensive operation, so get a robot to do it rather than...
Yeah. Nice. So we're now at the point where the likes of us as plumbers have got the big, you know, the core bits and the drill bits that we use, but this is at the stage where they've been laid, they've been turned, they're now in essence a complete bit, but they're still missing the tungsten carbide tips at the top. Now this is the furnace side of stuff now. This is where they put that tungsten tip in the end, and it's still very much, when me and Dave seen this bit, it was quite interesting really. It's still done fairly manually over where the furnace is. So I'll take you over now and show you just how the tips are put in, and then the machine that it goes through to get them tungsten tips just to stay in at the end. You just do what you're doing, it's fine. So do you want to talk us through this bit then, Andrew?
Yeah, of course I can. So we've got a copper braze, which for this sort of application is the highest grade of braze you can acquire. Okay, so all the copper braze is doing really is cementing the tip, the carbide insert tip, into the drill bit, so it won't come out.
Yeah.
So the copper braze melts at 950 degrees, okay? So they'll all be loaded up.
So we just dip the end of these bits with the, so it's already had the carbide tip put in it.
Yes.
So the carbide tips are now in it, and then just to seal those carbide tips,
you use the copper braze.
So it gets dipped into here, then dipped into there, put onto this conveyor belt, and it goes through the big furnace here. And what was tell us the interesting bit with here? So this is the furnace in operation.
So with the rising costs of power, what we've decided to do, run the furnace for 2 weeks on, 2 weeks off. Okay, now the interesting point about this is the sort of shrinking, the contracting and the expanding through, you know, thermal expansion.
Yeah.
So we've actually made a note of it. So when the furnace is up to temperature at 1100 degrees, okay, this point here is where the furnace is sat. When you lower it down to 400 degrees, it actually shrinks by that amount, the entire furnace.
So what they've done, when it's down, it says cold, but cold's 400 degrees,
400
isn't it?
degrees.
So when this furnace is running at 400 degrees, or it's off in essence, this little, where we marked here, or where the lads have marked here, is this point here. And then when it comes up to temperature at what? 1100 degrees, because of the expansion in this machine, that has just shifted, what, 3 inches across, and that just shows the heat inside here, just to get those tungsten tips melted. Is it melted the right word, or sealed?
The braze is melted.
So the braze is melted, but that's the heat generated inside there, makes that expand. But as the tips are running through this machine, so what is it, about 45 minutes?
45 minutes, yeah, 3/4 of an hour. So you've got 3 heating chambers, okay? So the first one, 900 degrees, 1000 degrees and 1100 degrees. So 1100 degrees, not only is the braze melted, but that is the optimum temperature for our material for heat treatment. It then reaches the air quench. So the drill bits are sat at 1100 degrees, and then we blast them with real cold air, okay? And that freezes the drill bits, and that is the quenching operation, solely using air.
Yeah,
okay?
And then it comes along here.
The rest of it is then the drill bits just reducing down to room temperature, so it's safe for the operators to remove the drill bits.
Right. So then, after 45 minutes, they come out, and again, this is the bit that sort of opened my eyes a little bit. You've got a guy at the end checking every single tip that comes through, just to make sure they are 100% perfect. If they're not, they go back onto the rack, and what they can be used twice. We can
heat treat them twice. If they're heat treated any more than twice, unfortunately we have to scrap them.
Yeah.
Okay.
So they get heat treated twice. After that, if they're no good, they go into recycling. But if we look, I don't know if you're going to pick it up, but through there, yeah, you can just about see it. That's the furnace up there. But yeah, and then it comes through on this conveyor, obviously loops back round. But they are thinking at the minute about possibly shutting it down.
We're going to do it 2 weeks on, 2 weeks off.
Right.
That seems to be the optimum time, because it costs more money to raise it back up to temperature. So the optimum time to drop the temperature but maintain production is 2 weeks.
Because it's not cost effective to shut that down for 2 or 3 days to get it back up to temperature.
You end up costing more.
So they're trialling it, seeing if they can shut it down for 2 weeks and then put it back on to save a bit of money, because we all know energy at the minute is just through the roof. So that's the drill bits coming out of there. These little stations here are amazing. Now, the guys aren't here now, they may be on their lunch, but these drill bits here, obviously what we use as pilot bits, you know, most plumbers, electricians, everyone's got these. And I just found it massively interesting that there's just a guy here and a guy there, and putting them on here. I think these are the ones, yeah, look, because they're going through, if we put that there, you can see it's obviously not straight. Now, I was watching them sat here, testing them, spinning them on here, into the machine, hand tweaking these to make sure they're dead straight. Just 2 guys doing it. And I just thought, in my head, I thought there'd be a machine to do that, but it was just so nice seeing 2 blokes sat there doing it by hand. Now, they were pulling these, and it's just about knowing that pressure just to straighten them out. So that's an old one, and then you put one they've done. It's absolutely perfect. Found it dead interesting. I love that bit. And then you've got that's an automatic straightener, isn't it?
This is automated straightening machine. So predominantly we let the guys do the shorter drill bits. We do up to mass produce up to 1 metre long.
Yeah.
So we let the automated machine tackle the metre long.
So there's your automated one for the longer ones. But yeah, the 2 guys sat there, still by hand, still sort of proper working, if you like, getting them perfectly straight. So we've got a 66mm core bit here, and obviously being an Armeg one, they like to get the branding on it, and they've got the little laser machine to do that. So this is where they do the lasering. There's one already done in there, but it takes literally seconds to do. So Andrew's going to pop one in there.
Laser one in. Close the door.
up.
Steady going. 45 seconds.
45 seconds to get it done. You can see it's just etching the top there. And I assume you can make a limited run of 50th anniversary ones or whatever just by changing the code in if you wanted to.
We can do. Certainly can do.
Yeah. But it's just nice that you got that little logo on it when it comes out. There you go, job done. Is that it?
Completed.
Sorted. I'll pick it up.
Yeah, of course.
There you go. Job done. Armeg 66mm core bit.
So everything's all in one, all designed to be used on hammer action. This is Class A engineering brake.
So that's designed to be used on hammer then?
On hammer action,
right, okay.
yeah. Absolutely.
There you
That's
go.
virtually through.
Just hold it up against there to see how far it's gone through. Yeah, so your gear will take all the way through, and that's gone through on hammer, as opposed to what we always used to do is put it through on just the drill. So how can that, well, what's been done to that to be able to use it on hammer like that?
The tungsten carbide tip, the hammer grade tungsten carbide tip that are designed to be used on hammer action. If you run that on rotary only, progress will be really slow.
Yeah.
And it'll just rub. They're basically chisels. It's not cutting, it's
Just
chiseling.
chopping.
But on an SDS machine, that's how the progress is made. It's a hammer.
Yeah.
So there's a piston inside the nose piece of the machine.
Yeah.
And it hits onto the end of the accessory. So a lot of people make the mistake when they're drilling with an SDS machine and absolutely leaning on it,
Yeah.
thinking they're going to make quicker progress. You just need to let it bounce.
As a rule, usually you'd, well, as a lot of people have done over the times, just used it on drill, not hammer, but as you can clearly see, with hammer it's gone through easy enough.
You get that kind of distance, I think, with dry diamond, you're probably looking about half an hour.
So that's the factory side of it, and then the other side of the wall, if you like, is where they do the packaging. So all the packaging's done in-house. You know, when you go to CEF or Plumbase or wherever to pick up your stuff, it's all packaged up by these people, the other side of the factory. So there we go, we've been down around the factory, seen exactly how Armeg are producing the products, and then we come up here, and as I called it earlier on, it's like the cool wall. It's every tradesman's dream, got a bit of everything here. But we saw the core drills being made. We saw how this was actually machined out of them solid bits of steel, Andrew?
Yeah, 34 chrome nickel moly 6.
So that was machined out, and then we also saw how the likes of the tips here were actually dipped and then gone through that furnace, and that was just dead impressive, the furnace side of things. Just an overview of all this then, Andrew. These are the products that are all made in-house.
Yeah, everything you see from here on this wall has all been manufactured downstairs.
Brilliant, all packaged up,
All packaged
ready
up
to
in
go.
the warehouse.
All these that we didn't, I don't think I did on these, because these are mainly electrician sort of tools, but you know, all those are done
Yep.
in-house. And again, I think we saw these as well.
We did see these. We saw these during the milling option.
Yeah.
So we missed the turning, unfortunately. We had a different product being turned. But yes, we did see the milling operation and the slotting operation for your insert to go in your scotch insert.
Yeah, because as we said, certain things are turned and machined and milled at certain times. You may do a run on these, I guess, and then the machine's then set up to do something else.
We saw the metre long ones being fluted.
Yeah, very good. So yeah, at the end of the day, this is all, as I say, British made here at Armeg, based, is it just outside Sheffield?
Yes, Dronfield.
Dronfield, yeah. So all British made, and it was just a brilliant opportunity to come here, have a look round. So a massive thank you to Andrew.
Very welcome.
For showing us the ins and outs of everything here at Armeg. I'll put all the links to Armeg's website and everything below, and I'm sure we'll be doing something with Armeg in the future.